Okay, continuing with our video lessons for 7th grade. Okay, this is our video lesson number 11. Okay, this is chapter 4, section 3. Okay, we're going to start talking about equivalent fractions. Okay, now the topics we have covered so far are going to help us with this topic. Okay, so the greatest common factor that we saw in the previous lesson, okay, is going to be very helpful for this topic. Okay, so when we're talking about equivalent fractions, we're talking about fractions that are equal, okay, in meaning, okay, but not in magnitude. Okay, so for example, let's say that I have the fraction 1/2. Okay, a 1/2, okay, that means that if we place it, okay, on a number line, okay, between 0 and 1, for example, okay, 1/2 is going to be here, okay, right in the middle. Okay, let's put it with another color just to make sure. Okay, and that is going to be the position of 1/2. Okay, so an equivalent fraction is going to be a fraction, okay, that is going to have different numbers, but it's going to have the same measure. Okay, so for example, if we still have 0 and we still have 1, okay, another equivalent fraction of 1/2, for example, is going to be 2/4. Okay, because it's technically the same measurement. Okay, the only thing that is different is that this number was divided in 2 parts. Okay, and this number was divided in 1/4, 2/4, 3/4, and 1. Okay, but if you notice, they are in the same position in the number line. Okay, the same thing is going to happen if I take this number line, okay, and I have 0 here, 1 here, and I divide it into 8 parts. Okay, so it's going to be the exact same thing if we do it in 8ths. Okay, this is going to be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 1. Okay, so if you notice, this point here is 4/8, and that is an equivalent fraction of 2/4, and 2/4 and 4/8 are an equivalent fraction of 1/2. Okay, so how do we know that they are an equivalent fraction? Okay, if I have 1/2 here and I multiply 2 on the top and 2 on the bottom number, I'm going to get 2/4. Okay, so that is how we know that it's an equivalent fraction, because if I multiply the same number on the top and on the bottom, I'm going to get the same number. Okay, what if I have 1/2 and I multiply 5 on the top and 5 on the bottom? That means that we have 5/10, and that is another equivalent fraction. Okay, because I'm multiplying the same number on the top and on the bottom. Okay, so I'm going to get an equivalent fraction. Let's do a higher number. Let's take 1/2 and multiply it by, let's say, 20. Okay, 20 on the top, 20 on the bottom. Okay, this is going to be 20/40. Okay, and this is going to be another equivalent fraction of 1/2. Okay, so this is how we get equivalent fractions. Okay, as long as we're multiplying the same number on the numerator than the denominator, we're going to have equivalent fractions. Okay, the same thing if I have, let's say, 1/3. Okay, if I'm using 1/3 as an example, okay, I'm going to multiply, let's say, 7 on the top, 7 on the bottom. Okay, and I'm going to get 7/21. Okay, so 7/21 is an equivalent fraction of 1/3. Okay, what if I take the 1/3 and I multiply it by, let's say, 100, just as an example? Okay, if I multiply it by 100, I get 100/300, and this is an equivalent fraction of 1/3. Okay, so the same thing is going to happen as long as we multiply the same number. Okay, let's say 12. As long as we multiply the same number on the top than on the bottom, okay, then we're going to have an equivalent fraction. Okay, so 12 over 36 is going to be an equivalent fraction of 1/3. Okay, and the same thing is going to happen for every fraction. 1 over 4, as long as we multiply the same number on the top and on the bottom, let's say times 4, it's going to be 4 over 16. Okay, equivalent fraction of 1/4. Okay, 1/4 times 10 times 10 is going to be 10 over 40, equivalent fraction. Okay, 1 over 4 times, let's say 15. Okay, same thing. As long as it's the same, as long as it's the same number on the top than on the bottom, doesn't matter. It's going to be an equivalent fraction. Okay, now why do we need to know this multiplication this way? Because I might give you this fraction and I want a equivalent fraction. So from this one, you'll need to get to this one. Okay, so the same thing that we do, that we multiply the same number on the top and on the bottom, in case we have this fraction and we want this one, okay, instead of multiplying, we're going to divide. Okay, so that's what we do with a greatest common factor. Okay, and it doesn't have to be the greatest common factor. It can be any factor. Okay, what if I give you a fraction like, let's say 20 over 25? Okay, if I give you this fraction and I want an equivalent fraction, okay, so I can multiply the top number times the bottom number, or I can divide by 5 on the top, by 5 on the bottom, and I have 20 divided by 5, 4, 25 divided by 5, 5, and I have an equivalent fraction. Okay, so it can go either way. It can go from this number to this number, okay, or from this number to this number, or from this number to this number. Okay, that is why we need the factors. Okay, what if I give you 36 over 60? Okay, that means that we can divide the top by, let's say, 4, and we can divide the bottom by 4. 36 divided by 4 is 9. 60 divided by 4 is 15. And even 15, we can divide it one step further. Okay, divide by 3, divide by 3, and I have 3 over 5. Okay, so instead of doing 2 divisions, I could have just taken a factor like 4 times 3, 12, okay, and gotten 36 over 60, and I get the greatest common factor, which is 12. Okay, 12 on the bottom, 12 on the top, and I get 3 over 5. Okay, so this is why the previous topic was very important as well. Okay, because getting the greatest common factor, I'm going to get the lowest fraction possible. Okay, now that is going to depend on the exercise. Maybe I'm asking for any type of lower fraction. Okay, but if I ask for a specific fraction, okay, as the lowest fraction, then you have to know the greatest common factor. Okay, so that is why the previous topic was very important. Okay, so let's start working with some exercises. Let's see. Let's take, for example, let's start simple. 6 over 12. Okay, I can divide. Okay, 6 over 12, I can divide 6 on the bottom, 6 on the top, and what do I get? 6 divided by 6, 1. 12 divided by 6, 2. Okay, so the lowest factor, the lowest fraction of this one is 1/2. Okay, what if I give you, let's try another one. But I give you 14 over 16. Okay, if I have 14 over 16, okay, that means I can divide by 2. Okay, let's try by 2. Okay, if we divide both sides by 2, I have 7 over 8. Can this one be lowered? No, because 7 is a prime number. 8 can be divided by 4 and 2, but 7 is a prime number. So we cannot go any lower. Let's try another one. Okay, let's try, let's see, 18 over 21. Okay, what would be a factor between the two of them? 3. Okay, divided by 3, 6 divided by 3, 7. Can it be lowered? No, because 7 is a prime number. Okay, so there we have the answer. Okay, let's try another one. Let's see. 16, for example, over 20. Okay, what would be the factor, the greatest common factor of 16 over 20? Remember that 16 can be divided by 2, that's going to be 8. Divided by 2, that's going to be 4. Divided by 2, that's going to be 2. And then 2 is a prime number. Okay, then 20. Okay, 20 can be divided by 2 is 10. 20 can be divided by 2 is 5. 5 is a prime number. Okay, so where we reach to the 5 is 4. Okay, so divided by 4, we get 4 over 5. Okay, 5 is a prime number. We can't go lower. Okay, let's try another one. Let's see. Let's try 25 over 35. Okay, this one looks pretty simple. Okay, we can divide by 5 on the top and on the bottom. Okay, and we get 5 over 7. 5 is a prime number. 7 is a prime number. We cannot go lower. That's the answer. Okay, now I want to include, okay, because you're going to find exercises like this. What happens if we have variables? Let's say that I have this one, 6a divided by 6a to the square. Okay, remember that since we have a fraction, okay, the 6 cancels with the 6, and the a is going to cancel the square. Okay, so the answer is going to be 1 over a. Remember that when we have a variable on the top and when we have a variable on the bottom, it's like we have to subtract. Okay, remember this. This is a rule. Okay, this is a rule for powers. Okay, if we haven't, let's say a to the 7 divided by 8 to the 3. Okay, when we are dividing powers, remember that what we do is, where is the biggest power? On the top. Okay, so the variable is going to stay on the top. Okay, and what we do here is that we subtract. Okay, so this is the same as having a to the 7 minus 3. Okay, so we cancel the 3 and we divide and we subtract 7 minus 3, and the answer is going to be a to the 4. Okay, a to the 4, sorry, here. Okay, so remember that we are subtracting. Okay, we cancel the 3, we cancel the a, and we bring it up, so it's going to be 7 minus 3. Okay, and a to the 7 minus 3 is equal to a to the 4. Okay, what happens if the bigger power is on the bottom? Let's say that we have a to the 5 divided by a to the 10. This is the same thing. The only thing is that this one is going to get canceled and we bring it down. Okay, so we're going to keep the 1 on the bottom, and then we're going to have a to the 10 minus 5. Okay, and this is going to be 1 over a to the 5. Okay, so remember that this is what happens. When the bigger power is on the top, then we bring this one to the top, negative. Okay, and if the bigger power is on the bottom, like here, then we bring this one to the bottom as negative. Okay, so it's going to be, and on the top we're going to leave the 1. Okay, unless we have a different number, it's going to be 1. Okay, so what happens with exercises that have powers? Okay, let's try, let me see, let's try this one. That's going to be number 7. Number 7, let's say 27 B C D divided by 12B. Okay, so what happens here? Okay, 27 and 12. Can we simplify those numbers? Yes, there is a factor that divides them both. Okay, 27 can be divided by 3, 12 can be divided by 3. Okay, so 27 and 12. Let's divide 27 divided by 3, 9. Okay, 12 divided by 3, 4. Okay, now if you notice, we have a B, so the B's get canceled. Okay, and then we have CD, and the CD stays on the top. Okay, so this is the answer. Okay, because if we have the same number, the same power, then they just get canceled because it's like dividing. Okay, let's do another one. Let's say we have 77 x to the 3 divided by 6x. Let's take this one. Okay, we have 77 x to the 3 divided by 6x. Okay, now we know that one of the x's will be canceled. Okay, now 77 and 6. Let's see if they have a common factor. 77 can be divided by 7, by 11, by 77, and by 1. And 6 can be divided by 2, by 3, and by 6. Do they have a common factor? No. Whenever we do not have a common factor, then we cannot simplify. Okay, so the numbers stay the same. And the only thing that we can simplify is the variable. Okay, so if we have x to the 1 on the bottom, it's like having x 3 minus 1. Okay, so that is going to give us 77 x to the square divided by 6. Okay, and there we have our answer. Okay, we keep the 77 and we keep the 6 because they do not have a common factor. Okay, if they had a common factor, then we can just divide. Okay, let's do another one. Let's try 49 t to the square divided by 7 t to the 3. Okay, let's try this one. Okay, now what happens with this one? 49 and 7, they are direct factors. Okay, so here we can just simplify directly. 49 divided by 7, 7. Okay, and we have it on the top. Okay, now the bigger power is on the bottom. Okay, so that means that we're going to keep the t on the bottom, and then we have t3 minus 2. Okay, remember that this 2 is going to come as negative. Okay, so the answer is going to be 7 divided by t. Okay, and t to the 1. Okay, because 3 minus 2 is t to the 1. Okay, and that's our answer. Okay, so in next class, the next class that we have live, we're going to do more exercises of this type. Okay, so remember to keep an eye on the class. Okay, it's going to be Friday. Okay, so make sure to tune in. Okay, I'm going to leave this video with some exercises so you can practice, and then on Friday for the class, you can tell me if you have any doubts or if something was not clear. Okay, so remember, for equivalent fractions, as long as we multiply the same number on the bottom, which is on the top, which is the numerator, and on the bottom, which is the denominator, we will have no problem. Okay, this means that this can be a normal equivalent fraction. Okay, and remember that it goes both ways. Instead of multiplying, we can divide, and that we get a different equivalent fraction. Okay, so as long as the only thing that you need to remember about equivalent fractions is that whatever you do on the numerator has to be the same in the denominator. Okay, if I multiply on the top, if I multiply on the bottom, okay, it has to be by the same number. And if I divide one number on the top and one number on the bottom, it has to be the same number. Okay, that is the only way that we're going to get an exact equivalent fraction. Okay. Okay, so make sure to check the link under this video. Okay, you're going to find some exercises. Sometimes they're going to be from the book. Okay, so you might see a picture from one of the exercises from your book. And on the Google Classroom, I will specify which exact exercises you need to hand in. Okay, thank you very much for your attention. And if you have any questions, please let me know.